Okay, we're looking at example 2.6. In this example, we have a boat or what is it, a canoe? We have a sailboat, a prototype sailboat hull, and they're trying to determine the drag on it. So what are they doing? They're sticking in this testing, they're putting a known flow through it, and then they're holding it with 3 wires. Okay, so for at the given speed of the flow, we have a tension in this cable AB of 40 pounds, and cable AE right here of 60 pounds, and we're supposed to determine the drag, which is going to be in this direction, right? We'll call that drag, and the force in cable AC. Okay, so let's draw a free body diagram, as we will do on many of these problems. Okay, so what point do we want to consider? Let's consider point A. So at this point A, we have this. We'll call it TAC, a tension in the cable AC. We have just a full up drag. We have T in AE, and we have this tension off in this direction. We'll call it AB. So let's figure out some angles. We'll call this theta. We'll call this alpha. So we know from the geometry here that theta, let's look at theta, tangent of theta is opposite over adjacent, so that's going to be 7 over 4. So that gives us that theta is 60.26 degrees. As the semester goes along, sometimes we'll find that you don't have to do that. You can just hold on to the numbers, but this one doesn't work out very easily, so it's just easier to do it this way. Tangent of alpha is going to be 1.5 over 4, so that's going to give us that alpha is 20.56. Why do I do that? Well, because I'm going to turn around, I'm going to do some of the forces in X and some of the forces in Y. I'm going to have 2 equations, and how many unknowns? We have drag and this tension, 2 unknowns. So let's start with the sum of the forces in X equals 0. So what forces do we have in X? Well, we have TAB. The X component of that is going to be what? Times sine of theta, which is 60.26. That's going to go to the left, so that's our only force to the left. So that, needs to equal, to T AC times, in this case, it's going to be sine of 20.56 plus the drag. And so that's our first equation, right? One equation. And then now let's look at the sum of the forces in Y equals 0. So here we have TAB, and it's going to be times cosine of 60.26, 60, and that's going to equal, no, I'm sorry, you're going to add that, that's going up, and we're going to add that to TAC times cosine of 20.56. Notice the drag has no y component of the force, so that just is all equal to AE, which we know is 60 pounds. So there we go. So we know TAB is given right here, right? It's given us 40 pounds, so it's jumping around. That's 40 pounds. This is 60 pounds. So this equation right here only has one unknown, and that's TAC. So it turns out that TAC is equal to 42.9 pounds. So that's our first answer. So the tension in this one right here is 43 pounds. And then we come plug that into the second equation, and that solves for D. And drag, when you plug that into there, is 19.67 pounds. So what's the key to this? The key is simply to do this free body diagram. It's all about the free body diagram. And then once you have the free body diagram, so do your equations, you sum of your forces in X and your sum of your forces in Y, and make sure you account for them correctly. So here we have an X, again we have our left forces are equal to the right forces, and here we have our up forces are equal to our down forces. And that gives us these final answers.